Hello and welcome back to our channel.
Today we are going to be talking about our experience constructing a roller coaster.
When we originally made the roller coaster, the initial hill was not built high enough, causing the marble to not gain enough speed to make it around the loop we constructed. We had to reconstruct the initial hill, giving it more height, which allowed it to gain more velocity as it went down the hill and into the loop. However, in our second redesign of the roller coaster, after the loop, the marble did not have enough velocity to make it around the turn. Therefore, we had to reconstruct the vertical loop to have a smaller radius to allow the marble to gain enough speed to make it around the turn.
Newton's laws of motion play a large role in this project. His first law of motion states that objects in motion tend to stay in motion and objects at rest tend to stay at rest unless acted upon by another force. This is represented in our project when the marble continued to stay in motion on the course until it was acted upon by friction. This law is also visible at the end of our track, where a barrier at the end of the course exerted a force on the marble, causing the marble to lose its kinetic motion. Newton's second law states that force equals mass times acceleration.
Newton's third law of motion states that for every action, there is an equal but opposite reaction. This is evident in our project because there is a normal force from the track acting upon the marble. However, the marble also does work on the track by giving the track some of its kinetic energy, causing the track to shake because it's flimsy.
In order to find the velocity of the marble at the vertical loop and the 270-degree turn, we use the equation distance equals rate times time, or d equals r times t. After calculating the velocity of the metal marble at the top of the vertical loop, we found that the average acceleration in this area was 1.70044 meters per second squared. The average velocity at the 270-degree turn was 1.49563 meters per second squared. Centripetal acceleration can be calculated using the equation v squared over r, where v is the velocity and r is the radius of the circle. For the vertical loop and the 270-degree turn, we did 3 trials each. This free body diagram below represents the forces acting on the marble. Normal force is the force of the earth that pulls the marble up perpendicularly. Mass times gravitational force represents the force pulling the marble down towards the earth. In order to find the normal force of the track on the marble, we use Pythagorean theorem, where mass times gravity squared plus mass times centripetal acceleration squared equals normal force squared. After doing this, we can use the equation force equals mass times acceleration in order to find the acceleration of the marble at the 2 points we analyzed on our roller coaster.
The law of conservation of energy states that energy can neither be created nor destroyed. However, energy can be transformed and transferred. For example, in this roller coaster project, some of the marble's kinetic energy is transformed to thermal and sound energy due to friction.
In order to prove the conservation of energy, we can use the equation initial potential energy plus initial kinetic energy equals final potential energy plus final kinetic energy. The equation for kinetic energy is half of the mass of the object multiplied by the velocity squared. The equation for potential energy is the mass of the object multiplied by its height and then multiplied by the gravitational pull.
However, the conservation of energy equation above does not take into account the work done by friction. Work done by as stated before, friction causes kinetic energy to be converted into other forms of energy such as thermal and sound energy. Therefore, we can use the equation potential energy initial plus kinetic energy initial plus work equals potential energy final plus kinetic energy final. To find the work done by friction, we plug our answer of the original equation into the equation work equals force times distance.
Mechanical energy is the sum of kinetic energy and potential energy. It is the energy contained in an object due to its motion and/or position. The equation for it is kinetic energy plus potential energy is equal to mechanical energy. With the variables, the equation is mass times gravity times height plus 1/2 mass times velocity squared.
Throughout the project, we showed resilience and persistence when we did not know how to incorporate the 270-degree turn into our roller coaster. We tried multiple times to design the roller coaster in a way that would allow us to incorporate the turn, however, many of our attempts ended in failure. Despite this, we did not give up and finally figured out a way to make the loop. This will help us in future projects by teaching us how to persevere through setbacks.
Some ways we contributed to the learning community was by helping another group in our class when only one member was present and the others were not there. We helped that person with her roller coaster as she tried to get the marble over the hill without it flying off. In addition, each person in our group helped each other by sharing our ideas, knowledge, and data with the others to help create our final project.
Throughout the process of designing the roller coaster, we realized that errors were made in the construction of the coaster, one of which was putting too much hot glue on the foam, causing the foam to melt, which may have hindered the path of the marble, causing the marble to lose velocity. Through this, we learned that the hot glue needed to be at a lower temperature in order to attach the foam to the dowels without the foam melting. This allowed our marble to run more smoothly throughout our roller coaster. We can assume that other human errors were also made while collecting data. Thank you for watching and hope you all enjoyed the video.